Hi, and welcome to Section 6.1, Video 2 of 2 parts. In the first part, we looked at a bunch of definitions with regards to angles. In this portion of the videos, we're going to look at two things specifically. We're going to look at length of a circular arc and area of a circular sector. I separated these two topics to just this section for a very specific purpose. These two topics will show up on exam 1, and it is very likely it'll show up on the final exam. These are problems that the math department likes to put on a final exam as problems, so we're going to focus a lot on it here. So first, we want to talk about the length of a circular arc. We have the following definition. In a circle of radius r, the length s of an arc that subtends the central angle so the central angle theta, we'll call it, and this is the important thing, it's theta radians. So the answer we're going to have is in radians. So if you're given this length and you need to convert it to degrees or something, we need to use that little trick we learned in the first parts of the videos for 6.1. But if we're talking about the length of a circular arc, if the circle has radius r, then the length s of the arc that subtends the central angle of theta is given by the following. S is equal to r times theta. This is one of the formulas you're going to want on your cheat sheet. It's going to be one of them you want to remember for the final exam, so that if this type of problem comes up, you're able to do the computations. So if we do some algebra on this, we also have the following. That theta is equal to s over r. So if we are told to find the measurement of the angle, theta, if we're given the length and we're given the radius, we can do that. And again, it's just, if you just remember this first formula, you can plug the values in and do a little bit of algebra. But if you want to have it on your cheat sheet as a quick guide, this would be the formula for that. Okay, I'm going to erase this. We'll look at an example. So we have the following example. Find the length of an arc of a circle with radius meters that subtends a central angle of 30 degrees. So this is how the problem will typically be worded, and this is where you have to look out. Because the formula was fairly simple. It was S equals R times theta, right? So you think, oh, 10 times 30, 300, I'm done. But it's not, because we have to have this answer in radians. And if we're going to have this in radians, we need to first convert this 30 degrees into radians. Then we can figure out, using this formula, what's the length of that arc. So if you remember, if we want to go from degrees to radians, what do? We multiply by pi over 180. So when we do that to 30, this is like 30 over 1. So the 30 cancels with the 80, gives us 6. So this is really pi over 6 radians. Now we can use this formula. So the length of the arc is r, which is 10, times theta, which in this case is pi over 6. Again, this is 10 over 1. So if we divide both of these by 2, that gives me 3. That gives me 5. So my answer would be 5 pi over 3, and in this case meters, because the circle was 10 meters. So the answer is 5 pi over 3 meters, not 300. We don't just do 10 times 30, and that's our answer. So that is truly the trick of these problems. And it seems like an easy enough problem, especially if it's on the final. It's like, oh, I just multiply 2 numbers and I'm done. But you have to be careful that your angle measurement is in radians and not degrees. Okay, so that is length of a circular arc. The other topic in this portion of the video is area of a circular sector. So what this is talking about is if we have this unit circle, or if we have a circle, and we're filling in some portion of it, what is the area of that? So if we want to think of it as pizza, what's the area of that slice of pizza? We have the definition. In a circle of radius r, the area A of a sector with central angle theta radians. So again, we have to be careful. If we're given a degree measurement, we have to convert it. So the sector is figured out with the following formula. The area A is 1/2 the radius squared times theta. So again, if you've got that cheat sheet and you're putting stuff on it, put this on it. If nothing else, it's a quick shortcut for your homework, so you don't have to keep flipping through your notes or flipping through the book. You can just go to that part. Oh, area of a circular sector, A is equal to 1/2 r squared theta. And again, make sure it's in radians. So let's look at an example. So find the area of a sector with central angle (60 degrees) if the radius is 3 meters. So the radius of the circle is 3 meters. We have 60 degrees. We want to fill in that area and find out what is the area of that circle. So again, first thing we need to do, convert 60 degrees to radians. So we're going to multiply by pi over 180. 60 cancels with the 80. 180 gives us 3. So this is actually pi over 3 radians. So then using that formula, area is 1/2 the radius squared, so 3 squared times pi over 3. So this is 1/2 times 9 times pi over 3. So the 3 cancels with the 9, gives us 3 left over. So this gives us 3 pi over 2, if we want our units, square meters, as the area of the sector. So again, the real trick of these is this part. Make sure you convert these things to radians before you start plugging them into the formula. Alright, well, that concludes the second portion of the video for 6.1, which concludes the videos for 6.1. We'll see you guys in 6.2.